let's say two variables x and y, and for any x value there is a y value, there is a sets of values. So 3, 2 will be maybe 5, 3 is minus 8, 9, 4 is minus 12, something like that. So this is called a relation x and y. These sets of values can be called a relation. Now this relation can also be said to be a function of, to be a function like y is function x, or these are all function, different way of writing it. So usually the alphabet f is more used. So this can be called a function only if for any value x, any x value, there is only a unique y value. If that exists, only then we can call it a function. So for any x value, it has to have unique y value like that, and like for any x value we can say that it has a unique y value. So this can be called a function. So there is a test that can be done for any graph, whether it's a function that's called vertical line test. So we have say xy here. Vertical line test is something drawing an arbitrary vertical line to see if that, say this one, draw a arbitrary vertical line, and when it cuts the graph, if it cuts only once, then this is a function. If not, if it cuts twice, then it's not a function, it's just a relation. Let's say this one, and let's have something like this. So if we take our vertical line, any vertical line, but if a vertical line cuts it twice, then this is not a function. This is a function, this is not a function. This is a circle, of course this is a parabola, this one, but not a function, it's a relation. Similarly this one is not a function. This one, the vertical line test, it passes the vertical line test, so this is not, this is a function, this is a relation as well as a function. So all functions are relations, but all relations are not functions. Those relations only for where the this x value has a unique y value will be called a function of x. Or anyway, now in order to find inverse function, we do a test similar, which is called a horizontal line test. That goes something like this. So we do the same thing, we draw a horizontal line to see whether it cuts the graph twice, and if once, only once, if only once, that function has an inverse function. If it cuts more than once, then it does not have an inverse function. So let's say this one, the one that passed the vertical line test, and this is definitely a function. So this is of the form x square 4ay. So y is equal to x square 4a, which is a function of x for y. But if we do the horizontal line test, it doesn't pass, it cuts twice, so it does not have an inverse function, because for inverse function it will have, when we make x the subject, we will have two values, so it's not this one is not a function, so the inverse function does not exist for this one. So we can do similarly for the vertical line test for anything, and we can see whether it has, like this one, sorry, this one, horizontal line it passes, and vertical line also, so it's definitely a function, but the inverse function also exists since it passes the horizontal line test. Similarly, if we check the circle, we saw that it doesn't pass the vertical line test, so it's not a function. Of course it doesn't have an inverse function as well, so doesn't. Now let's do one more, this one. It didn't pass the vertical line test, but this one's, since this is not a function anyway, but we can see that the inverse function exists, because or inverse function we can't say though, because it is not a function anyway. But let's see, this is y square 4ax. So for y value it has two, for any x value it has two y values, but if we see this one, y square 4a, so definitely this one is a function of, so x is a function of y. That's the thing. So basically this one is a horizontal line test, and similarly for any graph we can do a horizontal line test for any function to see whether the inverse function exists, and I will do maybe some more later. It's just the introduction.